Number is also known as a fraction. So a rational expression is an expression that is a fraction. But it's a fraction that might include polynomials in it. So when we want to simplify or put in simplest form, we need to use some of the ideas that you used when you had regular number fractions and then apply them to polynomials. So what that means is you're going to be looking for things that can cancel in the numerator and the denominator, things that are equal. However, you can't cancel out things like this 10 here because they're part of a sum. You can only cancel out factors, things that both the numerator and denominator could be divided by. So we have to break them down into factors first. Yes. Oh, that's nice. But you're fine there? Okay, that's good. Sometimes it's a habitual thing, so that's very nice. Nice to know you love each other. So, so we need to factor. So just to remind you of factoring, you need to take a look at this last number and find things that could multiply together to give you the 10, that when you add them, you get 7. So this numerator, when you factor it, what are you going to get? Yes. X plus 5, x plus 2, good. And here we're looking at the negative 10. And what numbers that are multiplied together give you negative 10, but then when you add them, you get negative 3? Negative 5 and positive 2, good. So we do that factoring process. Now you guys are getting good enough that both of you did that in your head. That's fantastic. That's really what is great to do. But if you need to write yourself a little chart, you're still asking yourself that same question. What numbers multiply together to give you this, but when you add them, you get the middle, because when you multiply a binomial times a binomial, you're distributing to both things, and you end up with x squared plus 5x plus 2x plus 10, which when you put it together gives you this. So we factor it. So first step would be factor, so make sure you write that down. Second, you're going to look for what can be canceled out, because you know that when you cancel things out, you're really dividing the numerator and denominator by the same thing. So you look for common factors. So what are our common factors here? X plus 2 and x plus 2. So those are the things that can be crossed out. So when we cancel, okay, we end up with our simplest form. But we have to then look to make sure that we count all the restrictions. Anything that makes a 0 in the denominator is off limits. So we have x plus 5, x minus 5 is our simplest form. So there's one obvious and one unobvious thing that would be a restriction. So what's one thing that x can't be? 5. X can't be 5 because we would get a 0 in our denominator here. But there's another one because the steps actually matter. So if there's anywhere, even in the steps, that you get a 0 in the denominator, then it also has to be restricted. So the other restriction comes from this one that we canceled out. X also cannot be almost not negative 2. So x can't be negative 2 because even though we ended up canceling it, it still would mess it up if we had to plug back into the original. So x can't be negative 2 and x can't be 5. Simplifying these polynomials would be good for making sure that you can plug in numbers more easily. It's also good that if you were needing to graph it at any time, you would be graphing a simpler thing. But you have to keep in mind here would be some kind of an asymptote, or in this case for the negative 2, it would be one of those removable holes in the graph because it's found in numerator and denominator.
So what you're saying is like it can't come out 3-0. So
yeah.
We already canceled out be x plus 2 now? Why is that in part one?
Because honestly, this is making it in simpler form, so you could do math more easily if you needed to plug in for x, so it simplifies it. But the actual original expression is here. So if you plugged in a -2 into the original expression, you'd get a 0 in the denominator, and you wouldn't be able to
Oh, okay,
actually
okay.
cancel the answer.
All right.
This simplifying is a way of making it so your work would be easier. It's like a shortcut if you did need to plug in those x's
Okay.
with
So,
values. And
wouldn't it also be x is not -5? Or is that just
Oh. -5 would give you 0 in the numerator, and 0 in the numerator is fine because that would just give you 0. That actually would give you, that would give you a point actually on the x-axis. It would give you an x-intercept. So that's fine. You have to watch out for anywhere in any denominator. So all through the process, if you end up with something somewhere that would give you a 0 in some denominator in any step, that becomes a restriction and you can't have that happen. So look for the obvious ones, but then look for the ones also that got canceled out for restrictions. All right, let's look at another one. We don't want to forget how to do these. We did these all the way back in Algebra 1, but we don't want to forget how to do them. They're already in what we call factored form because it's all products. Does anybody remember, first of all, what do we do with the 24 over -6? Just simplify it into how much? 4 over -1, or traditionally you'd end up with a negative in the numerator. So -4 up here in the numerator. Who remembers what happens with the x's? Subtract the exponent, good. So you get how many x's? 1x located in the numerator or denominator? Numerator. And here, 1y in the denominator, good. So here, 24 divided by -6 gives you -4. There are 3 x's at the top. 3 x's at the top. And there are 2 x's at the bottom. Okay, and we would probably never write this out again, but one will cancel and another one will cancel, and we're left with 1 at the top. Just for those that don't remember what was happening on here. And up here we had 2 y's at the top and we had 3 y's at the bottom. And so when you think about it, this one will go, this one will go, and you're left with 1 left over at the denominator, and that's why, how that works for anybody who wasn't seeing it in your head. But like I say, these we had done a long time ago. The restrictions are x can't be 0, x can't, and y can't be 0 also. Because once again, no zeros in the denominator are left over. You always want to finish it off by figuring out what x and y are not, or what variables are not allowed to be. You still have everybody? 24 divided by -6 is -4. And we put it on the top because really, if you're reducing this, you're dividing both numerator and denominator by -6. And the denominator turns into a 1. Like regular reducing fractions, you look for the greatest common factor and then divide. Yep. And this is why we do this and talk about it, so that in case anything is slipped out of your math mind, it can get put right back in where it places, reconnect it. Yep.
So basically doing through considering like x to the power of 3 and x to the power of 2, which we're basically like whichever one has more, that side gets the points, I guess you could say.
Yep, absolutely. That's the easiest way to think about it. Wherever there are more x's, that's where the x ends up. Wherever there are more y's, that's where the y ends up. That's exactly how I think it through, David. It makes it easy to think through. It's actually meaningful that way because you can actually see them you know, what you're probably doing is you'll see them in your mind where they can cross out. All right, let's look at the next one. Okay, now, this denominator looks like it would be easy to factor, but what we really need to do is we need to reconfigure this so that we get the highest exponent first. So, yeah, so we'll bring the negative x squared out to the front and then leave the negative 2x here. And then will the end be a -8 or a +8? +8. Because remember, you're taking the whole thing and there's a plus actually understood in front. So first we'll rearrange it. Okay. Right, we've rearranged it, but it's also, we also don't want to factor when there's still a negative here. So we're going to factor out a -1 if the first term turns out to be negative, just to make your factoring a little easier. So when we factor out a -1, you end up with -1 times x squared plus 2x minus 8. And it is an important step in your whole process so that when you're factoring, your -1 is just kind of hanging out there and it can wait till the end. But you're going to factor then x squared plus 2x minus 8. So let's see, when you factor x squared plus 2x minus 8, what number times itself gives you -8, and when you add it, you get 2. What is it? 4 and -2, okay. So 4 and -2 for that part. Put this here. Oops, here we go. -1 times x plus 4, x minus 2. It's not crossed out yet, but it's going to end up being. So when you factor this one out, you get -2, -3, okay? So -3, -2. And then we see that they're in common, so they can be canceled. Because you divide both sides, both numerator and denominator, so they're gone. And we have this. And then just to make it nice, we clean it up by redistributing the -1. So we have that, and that's our nicest way to put that answer. The reciprocal of, okay. Oh, you're thinking about conjugates maybe? Because we're not trying to rationalize a denominator, and honestly, that's actually not going to help us in this case. That would actually make it more complicated instead of simpler. It only is really helpful if you have irrational numbers such as square roots or imaginary numbers such as I, then the conjugates can be used. Otherwise, it's not going to, the conjugates won't help you at all. So what's our, what are our restrictions? What can x not be? 3? 3 or 2, right. Why 2? Answer the, who can help answer that?
Because it's in the denominator, and if x was 2 minus 2 is 0 times whatever x minus 3 is.
Yeah. So the factoring steps do 2 things. First of all, it shows you what can be canceled out, but then also it provides you with a good way of seeing what the restrictions are going to be. Anything that would give a 0 in any step is a value that's not going to work. So we have this. Even if we went back to the original problem, you'd end up with a 0 in the denominator, which you just can't have. So you're always looking for, can I factor it? If I can factor it, I need to factor it first before I start canceling out. And then I can cancel out whatever is needed. All right, and we have this one. And I put this one in because it's one of those type of problems that even though it looks easier, sometimes people get tripped up a little bit on it. because sometimes people forget how to factor the easier ones. And I know that sounds weird, but I've been at it enough that I know that it happens. So first reorder this. And when you reorder it, you're going to see that there's something a little bigger than a -1 that can get factored out. -4, right? So -4, once we reorder it, -4 can actually get factored out of both. If there's a negative at the front, you want to either factor out -1 or the greatest negative factor so that you don't have to deal with that negative factor anymore. So -4 factored out gives us x minus 3. How about when we factor this denominator, what do you get? Okay, I heard two things. I heard x minus 3 squared, and I heard x minus 3x plus 3. One of those is the correct answer. Okay. If you think it's x minus 3 squared, I want you to put up a number 1 on your fingers. If you think it's x minus 3x plus 3, I want you to put up a 2. I want everybody to give me some input. Okay, almost everybody's giving some input. Okay, and also I gotta, all right, so, okay, so, yeah, most of you came along with the right conclusion that it is the second one, x minus 3, x plus 3. Right, because they have to cancel out. When you distribute x times x, x squared, plus 3x minus 3x minus 9. So those middles have to drop if you are thinking that through. Then in common, we have the x minus 3s, so they will cancel. Yep. So the x plus 3 doesn't cancel, just the x minus 3s. And then what are our restrictions? 3 and -3, both of them. X can't be 3, x can't be -3. Yep. Because, yep. It would somehow give you a 0 back in the beginning. And this one's a little easier to see. If I plugged in 3, 3 squared minus 9, 9 minus 9, 0, denominator falls apart. -3 times -3 gives you 9, minus 9, 0, denominator falls apart. So we can't have that. Okay, now you remember when we had fractions and you had a fraction times a fraction. You could do something that we call cross-canceling to simplify those fractions, right? We can do that also when you have rational expressions. They're really just kind of like beefed up fractions. So what you need to do here, this one actually is hiding 3 factoring problems and then looking for what can cancel out. So just take a minute. I want you to factor each one of these 3 factoring problems. And then we'll look and see what we can cancel. So I'll put the video on pause for a second. Now looking at the factoring, let's just check these out here. You should have had x plus 3, x minus 2 here, plus 5, minus 5 here. Do watch out for that thing somebody was talking about earlier. Do watch out to be sure that you are getting the difference of, we have the difference of 2 squares that it factors out like this, not as a square of one binomial. And then this one for the last one. So what gets to be canceled out? X plus 3 cancels. X minus 5. Now remember there's hidden parentheses here. This is its own grouping symbol. So x minus 5 gets canceled out. Question? Yes. There's the canceling out. X minus 2 times x plus 5 over x plus 1. To make it look great, you should multiply it back out again, because you've canceled everything you can, so, depending on
Oh,
the context of the problem, so you'd have to multiply x times x, -2, distribute twice, x squared plus 5x minus 2x minus 10. X squared plus 5x minus 2x minus 10. And then put them together, like terms together. This is as simple as it's going to get, but that's still way simpler than this thing that we started out with. And then you do have to go back and ask about your restrictions. What values will mess up any step? -3, 5, and -1. Because any one of those numbers would give you a 0 in the denominator somewhere. So we can pick any values to put in except for 5, -3, -1. What happened to here, this 2? First, x times x, x squared, outer, for restrictions, yeah. It's an enumerator, so it's okay. It's just, it can't be as a denominator. Okay, good question. Okay. A second. No, I don't want that. That doesn't work. Sorry. Now we'll take a look at these. I know you've been busily factoring them. So we factor each one of the pieces. And when you do that, this top one, don't forget the ones where you're just looking for a greatest common factor. So the 2 comes out. 2 times x minus 4. Difference of 2 squares, don't forget those. X plus 4, x minus 4. You're looking for numbers that when you multiply them, you get 4. And when you take those factors and add them, you get 5, which would be 4 and 1. And then here, 4 times 4 gives you 16. But when you add them, you get 8. So you have this x plus 4 squared. It is a little easier for canceling out if you write it as x plus 4 times x plus 4, so you can look for the things that'll disappear for you. And we end up with an x plus 4 and an x plus 4 left over. And I noticed when I was walking around, some of you canceled out this way, and some of you canceled out this way, but you're still left with 2 x plus 4s either way. And they're both just right. So when you finish this out and you distribute, we end up getting this one back this time, just because everything else canceled. 2x plus 2. And then your last thing is always just to look for the restrictions. So what are those restrictions? X can't equal -4. Anything else? 4. -1 is okay. That's a numerator issue. We can have a negative, we can have a 0 in the numerator, we just can't have it in the denominator. So x can't be -4, x can't be +4. And then that's always your last step is, what are my restrictions? Your answer, your simplified form is this, but your restrictions are an important part of your final answer to finish it off good. All right, then one more. We have a negative exponent here. Who remembers what you do with a negative exponent?
You don't
I like that. Okay, so for those that didn't hear him, he said you pray for it so it becomes positive. But That's not going to help us in the math problem, but it's a really good thing. You should always pray for somebody so they become positive. If you want to take a negative exponent and make it positive, it's a reciprocal, so you can bring it to the other side of the fraction bar. Ah, so let's do that. So when we bring it, well, we can also cancel out the 3 and the 6 because the 3 and the 6 have a common factor. So we could do that first or after if we wanted to. Our negative becomes positive. When we bring it into the reciprocal, we bring it to the other side of the fraction bar. So our 3 and 6, divide numerator and denominator by 3, you get 1 over 2. And x squared times y to the third. And then we need to think about what's happening with the x's and the y's. For the x's, are we going to be adding or subtracting exponents? For the x's, subtracting, because there would be 2 up here and 5 down here, so you know you're going to be getting rid of some of them. So you'll have how many left? 3 in the denominator. 3 x's in the denominator, because think about them all written out. 1, 2, 3, 4, 5 down in the bottom. 2 of them at the top, but then we're only left with 3 in the denominator. How about the y's? All in the numerator, how many of them? 7 of them left in the numerator. So 1 times 5 is 5. 7 y's in the numerator. 5y to the 7th over x to the 3rd. And I didn't write down restrictions here. But I should have. Our restrictions should be what can't be 0, or x can't be 0. And here's an interesting one. What about y? Y can't, well, y can be 2. 2's not. Y also can't be 0. Okay, even though, listen, guys, even though we brought the y up to the numerator to get rid of the -3, okay? Keep in mind that in the denominator of the denominator, this one is really technically 1 over y to the 3rd, so you still have a divided by 0 in there somewhere, so you still can't get y being 0. So just watch out for that. If it's in a denominator anywhere, you have a problem. So we have that. And then that concludes today's lesson.